I am an AI developer. My days are spent crafting training, wrangling complex algorithms. I build the very tools that are now promising to reshape my own profession, so I had a simple, slightly terrifying question. Could an AI do my job for a day? I decided to find out. For a full 24 hours, I made a pact with myself. I would not write a single line of production code. Instead, I would become a manager, a prompter, a critic. I would give my daily tasks to a suite of AI coding assistants. I wanted to know what would happen. Would my productivity soar, or would I spend the entire day cleaning up a digital mess? The results were not what I expected. This was not a simple story of AI is good, or AI is bad. It was much more nuanced, more interesting, more important for anyone who writes code for a living. The experience was a roller coaster of incredible speed, subtle errors, moments of genuine surprise. To ensure this experiment was fair and generated useful insights, I needed a clear and repeatable setup. The plan was simple: pit AI against my benchmarks on 3 development tasks: easy, medium, and hard. I wanted to simulate a typical day, not a controlled laboratory environment. The tasks were pulled directly from my team's project backlog. For the AI arsenal, I chose state-of-the-art tools: ChatGPT-4, Claude 3, and GitHub Copilot integrated into my editor. My workspace was set up for maximum observation. Main monitor with Visual Studio Code open and ready, GitHub Copilot active with subtle suggestions. On the second monitor, a ChatGPT window where I'd craft prompts and a Claude window for longer context and nuance. I used a simple timer app to clock every phase: time to write the prompt, time for the AI to generate a response, time to debug, time to refactor, and time to integrate the AI's code into our project. I also set up screen recording software to capture the entire process. The ground rules were strict. I was forbidden from writing any functional code myself. My role was to translate business requirements into precise prompts. I could copy, paste, and run the AI's output. I could ask the AI for revisions, even ask it to debug its own code. My contribution was purely directive and corrective. That constraint forced me to rely entirely on the AI, and clearly exposed its strengths and weaknesses. At the beginning of the day, a sense of unease settled in. As a developer, my identity is tied to solving problems with code. Handing over the keyboard felt like a musician handing over their instrument. I'm paid to have control, understand details, make precise decisions. This experiment forced me to let go, trust the process, document everything with an open mind, prepared for breakthrough efficiency or complete frustration. The first challenge was a classic bread-and-butter task: creating a new REST API endpoint. The requirement was straightforward. I needed a POST endpoint at the root, API v1 users, that would accept a JSON payload, username, email, validate the inputs, and return a success message with a newly generated user ID. This is a task I have done hundreds of times. Manually, it would take me about 15 minutes. I fed a detailed prompt to ChatGPT, Node.js, Express, the exact route, the expected request body structure, the desired JSON response format. In a stunning 2 minutes, it produced a complete block of code: route handler, input validation using a popular library we already use, even an error handling snippet. It was fast. Incredibly fast. My 15-minute task became a 2-minute copy and paste job. However, perfection is in the details. The AI's code was about 90% of the way there. First, it hallucinated a function name for saving the user: db.saveuser, instead of our convention user model, .create. A one-line fix. Second, it missed validating the email format. I added a simple regex check. Another minute or two. After those edits, the endpoint worked flawlessly. It had even generated basic unit tests covering a success and a failure case, a fantastic starting point. A clear win for AI-assisted development. The AI acted as a massive accelerator for boilerplate and structure. My role shifted from typist to focused reviewer, saving over 10 minutes and reducing cognitive load. AI handled the first 90% with speed. I handled the context-specific 10% with judgment. On to something trickier. The second challenge was a beast of a different nature. It was not about creating something new, but fixing something broken. A stubborn bug in asynchronous data processing. Under heavy load, the app would intermittently crash with a vague, hard-to-reproduce error. Complex promises, callbacks, a classic recipe for race conditions. I had already spent 30 minutes the previous day adding logs and tracing execution without a breakthrough. Instead of asking it to write code, I changed my approach. I fed it the problematic code, the cryptic log, and the symptom. The application crashes under high concurrency when processing these asynchronous tasks. How could it understand timing issues from a static code block and one error message? The machine had no context of the live system. In just under 5 minutes, Claude responded, not just with a fix, but the why with stunning clarity. It identified a potential race condition. One async operation accessing a resource another hadn't finished initializing, and highlighted the exact 2 lines competing. Solution: wrap the critical section in proper async await, and use promise, all to ensure prerequisites complete before proceeding. I applied the suggested refactor, about 10 lines, and ran our load test. Immediate and conclusive, the app was stable. The crashes stopped completely. The AI found a bug in 5 minutes that had stumped me for over half an hour. A paradigm shift. The AI wasn't just a code generator, it was a powerful analytical partner, a pair of digital eyes spotting complex patterns in code and logs within human speed and accuracy. Time to raise the stakes. For the third and final challenge, I escalated the complexity significantly. This was about system design, APIs, data storage, asynchronous processing, and interactions with other parts of our system. A first draft usually takes me 2 hours. I crafted a very detailed prompt. Users upload an image. System generates 3 thumbnail sizes. Stores in a cloud bucket. I asked for a complete architectural proposal, services, REST APIs, data flow, and tech recommendations. In about 10 minutes, the AI returned a clean design, a fantastic starting point. It suggested an API gateway to handle uploads, queuing via AWS SQS, a scalable worker service to generate thumbnails, and storing results in S3, with sample API definitions and a clear sequence diagram. The structure was sound, scalable, cloud-native, saving me hours of initial drafting, a perfect v.1, but the limits were clear. The design, while clean, was naive, missing several critical edge cases. No mechanism for failed jobs, no plan for corrupt uploads, and no security considerations, authentication, malware scanning. It recommended a library with known performance issues, and outside our standard stack. My role shifted from prompter to senior architect. I filled in the gaps, added resilience with retries and dead letter queues, and applied our specific constraints. A strong foundation, but not production-ready without human judgment. Let's talk speed, quality, and hallucinations. After 24 hours, prompts, pastes, reviews, it was time to tally the results. The data painted a clear picture. On pure speed, the AI was in a league of its own. For raw generation and initial analysis, the AI is exponentially faster, but speed without quality is a recipe for disaster. Here the story balances. For the REST API, initial quality was around 90%, minor, context-specific tweaks. For debugging, the diagnosis was flawless. For architecture, closer to 60%. A good skeleton, missing resilience, security, and context. Quality drops as complexity and ambiguity rise. We must talk about errors and hallucinations. Copilot suggesting wrong argument order. ChatGPT importing a library that doesn't exist. Incompatible library picks. These are dangerous because the code often looks correct, and a junior or a tired senior might not catch them without rigorous testing. Final scorecard. It's a trade-off. You gain tremendous speed on the initial 80 to 90%. The cost is needing a human expert to finish the last 10 to 20%, catch hallucinations, add business context, handle edge cases, ensure security and scalability. The AI is a brilliant but sometimes unreliable junior developer. It gets you most of the way there, fast, but you must supervise, review, and test with an expert eye. This 24-hour experiment illuminated a clear division of labor in modern software development. AI is a force multiplier for tedious, repetitive, pattern-heavy tasks, generating boilerplate, endpoints, standard functions, configs, in seconds. It's also incredible for learning and exploration, parsing dense code and cryptic logs to find patterns humans might miss. But humans dominate where real understanding and judgment are needed. Architecture, business goals, team conventions, organizational context, and subtle security implications. The developer's role is evolving into human in the loop. The architect, the reviewer, the final arbiter of quality. We're shifting from pure code production towards system design, critical thinking, and prompt engineering. The most effective devs won't be the fastest typists, but those who best leverage AI. The AI is a pair programmer, but you are the senior partner, guiding the process and making the final calls. Be transparent using AI-generated code, check licenses, don't violate policy or open-source agreements, be hyper-vigilant on security, never paste sensitive proprietary code or keys into public models. Call to action. Start small. Next unit test? Ask an AI. Stuck on a bug? Share the snippet and error. Generate documentation. Explain legacy code. Treat AI output as a draft, not gospel. Review it. Test it. Learn from it. The sooner you partner with these tools, the more effective you'll be. Next, I'll test large-scale refactors across repos, strict style adherence, and complex security vulnerabilities, not just simple bugs. The key skill is writing great prompts. The quality of the AI's output reflects the quality of your input.